Okay, we said graphs like this are both one to one and on two because it's constantly increasing, which makes it one to one, one to one. It's going to pass the horizontal and the vertical line test. It's a one to one function. And it's on to because the domain is all real numbers. You can go out as far as you want to the left and the right, and you can go up as high as you want and down as low as you want on the range. So the domain and range are both the same. Okay. Linear functions. This one is linear right here. Anything with like a square root's not linear. This one's linear right here. Linear. That one's not linear because it's got a squared on it. This one's linear because it's a horizontal line. Y equals 1/2 is a horizontal line. Looks like this. Wouldn't be dashed, but I'm just dashing it so it doesn't get confused with the x-axis. This one's not linear because you can't have x and y multiplied together, right? So there were 3 linear ones and there were 4 nonlinear ones, okay? Just like on the practice test. The x-intercept, let's think about that for a second. The x-intercept is when the y is going to be 0. So this is our y value. Where is the y 0? 5. Okay, so some people had these turned around. 5 is the x-intercept. The y-intercept is when the x is going to be 0. I always put these down. It keeps me straight, right? So that's going to be 100. Okay, so, like I just said, some people had 100 here and 5 there. I saw that. On the next one, number 4, this one has line symmetry because if you reflect it over this line, it's going to land right back on top of itself. This part's going to go right over there to that part. This part's going to go here. This one, none, no symmetry. This one has point symmetry. If you rotate about that one 180 degrees, this guy's going to come right down there, land there. And this part down here is going to land right up there. Okay, but it's not about the origin. It's just about that point right there. So this one's point. This one's line. Okay. Down here, let's see, it said find the x values for the relative minima. So there's an x value right here at -1, okay, and there's an x value over here at like 3 something or other. What is that like? Or no, it was 1, 2, 3, and a little bit more. Is that right? So yeah, 3.3 is what they think it is right down here, okay? On number 6, we've got which function has it as you go to the left, x approaches negative infinity, means as you go to the left, y goes down. So let's see here. This means down, and this means left. So I want an arrow on the left going down. That one does, that one does, and that one does. So it's F, whatever that letter is, and K. Is that a J right there? So J, K, and F. And the next one, number 7, says which one has a lesser minimum? Okay, so the minimum is described right there. The minimum value is -6. The minimum is right here at 0. So the F function has the lesser minimum. Now it says down, print not supported on this item. Oh boy, we're going to have a hard time doing the corrections on that. I'll switch over to my other program. So the party that she's planning, it's going to charge how much per kid? $7 a kid up to 10 kids, right? So we're looking for 7x up to 10 kids. Yes, yes, yes. Okay, so check mark. We only eliminated one answer right there. Now it says, however, you have more than 10 kids, it's going to have a $20 fee plus $4 a kid. So now we're looking for plus 20 and 4x. Yes. I see the issue, right? So it says price per child. Okay, so if there are more than 10 kids. So right here, see it says 4x plus 20, more than 10 kids. This one down here is 4x plus 20 equal to 10 kids. See how they're both equals here? Boy, that's a tricky one. If you pick this one, you were so close, but you want this one because you want the one that's more than 10 kids, okay? Boy, I hope I'm making that clear. We got to switch over and look at number 8 and 9. So let's get over there to the test, and we're going to open up the test. Come on. Let me see here. I forgot to hit save. Okay, so that should fix that. Okay, let's go over here to content. We're trying to get to problem 8 and 9. Thanks for your patience. And I want you to do all these corrections on the back of the test in a or in a coloring pencil on the front side. Like, well, it makes sense to do them right by your problem. I don't know what I'm talking about. I'm just rambling, trying to fill up time here. So here we go. Problem number 8 is right here. Okay. And 8 said, oh, yeah, we're supposed to graph this thing, right? And it says the intercepts are 0, 3, and 2, 0. So let's do that right now. So here is 3, and here is 2, right? And so, shoot, I need a picture of that. And this is the one that got messed up on the computer grading system, because you guys had a lot of you had this as being correct, and it marked you wrong. So let's graph that real quick here. And so this is 3, this is 2. I'm going to connect those 2 points together with a straight line. And that's how you do number 8. Number 9 looked like kind of the same thing. You're supposed to graph it, right? And it's this equation, 3x minus 4y equals 16. So this was number 8. 3x minus 4y equals 16. And this is number 9. If we stick a 0 right there for x, we get negative 4y equals 16. So y equals negative 4. So on your graph, you wanted to come down to negative 4. And then if we stick 0 in for y, we get 3x equals 16. And x comes out to be 5 1/3. So you come out here to 5 1/3. That's why they had a third on the graph. And you connect those 2 points together like that. Hey, I'm going to have to do another video for the last 3 or 4 problems. Okay, thanks for watching.